Hey everyone, it's Justin here again, and in the last video we learned how to solve for one variable, even when there are several in the equation. In this video, we're going to be using that knowledge to solve some common formulas used by mathematicians, architects, scientists, a lot of different people in a lot of jobs. There are a lot of formulas used by people in different professions. We couldn't possibly cover them all. Instead, we're going to do a few examples like this one to give you an idea of how it works. Then, no matter what you are when you grow up, you'll know what to do. This one has three variables, A, B, and H. A means the area of the triangle, the B stands for how long the base of the triangle is, and the H stands for the height. We're going to practice solving both for B and for H, because we're given A, and it's important to know that you can solve for any variable in a formula. First, we're going to solve for B. We're doing two things to B, multiplying it by 1/2 and multiplying it by H. Multiplying by 1/2 is the same as dividing by 2, so to cancel it out, we'll multiply by 2. Now we've got 2A equals BH, so we're halfway there. To remove the multiplication by H, we divide by it. So B is equal to 2A divided by H. So if we knew the area and the height of a triangle, we could use this to find the length of the base. Now, if we want to solve for H, the process is nearly the same. First, we just multiply by 2 to cancel out the 1/2, and then we divide the B off the H. So the height of the triangle is equal to twice the area divided by the base. Here's our next example, the volume of a cylinder. This one is used a lot in architecture, manufacturing, and product packaging. The V stands for volume, the R stands for the radius of the circle on both sides of the cylinder, and the H, once again, stands for height. We can solve for either H or R, but I know what you're thinking, why not that weird symbol right after the equal sign? That's pi. And it's not a variable, it's a number. Pi is equal to 3.14159265358979, and a bunch more numbers forever and ever and ever. But you'll learn all about pi in geometry. The point is, it's a certain number, not a variable. So we don't need to solve for it. So with that said, let's solve for H and R. Solving for H is pretty simple. We're multiplying H by both pi and R squared. So to solve, we have to undo both multiplications. Now we could do this one at a time, but let me show you a cool trick. Since this is all one big multiplication, we could think of it as pi R squared times H. And we can undo it with one big division. Dividing by pi cancels multiplying by pi, and dividing by R squared cancels the R squared being multiplied, leaving us with H equal to volume divided by pi R squared. Solving for R is almost the same, but with an extra step. So first, R squared is being multiplied by both pi and H. Since it's one big multiplication, we can use the same trick as last time to cancel it with one big division. So now that we've got R squared is equal to V divided by pi H. But wait a second, we want to solve for R, not R squared. So how do we cancel out squaring? The opposite of a square is called a square root. So we use a square root on the R to cancel the square. And we have to do it on the other side too. Be careful here, we have to square root the entire side. So the square root goes over everything. And now we're done. R is equal to the square root of V divided by pi H. So if we knew the height of a soup can and how much soup it holds, we could find the radius of the can without having to measure it. Our next example is the Pythagorean Theorem. This formula is used to find one side of a right triangle if you already know the other two. A, B, and C are just names for the sides of the right triangle, with C being the longest one. We're going to solve for C and A. We could also solve for B here, but it would be exactly the same as solving for A, which you'll see in a second. So let's start with solving for C. It's going to be really easy because C is already by itself on the right side of the equation. The only thing we need to do is cancel the fact that it's being squared. So how do we do that? Square root it. Make sure to square root the whole left side. So C equals the square root of a squared plus b squared. Before you get any funny ideas though, it won't cancel the exponents on a or b because one square root can only cancel one square, not two squares separated with addition. To solve for a, first we're going to subtract the b squared away from it. Then square root that to cancel the square. So a is equal to the square root of c squared minus b squared. And like we said before, solving for b would look basically the same, except we would subtract off the a squared to start instead. Final example, the formula for converting temperatures from Fahrenheit to Celsius. There is only one variable we could solve for here, so let's solve for F for Fahrenheit. Remember, the order for undoing operations, SADMAP. That part in parentheses cannot be undone until everything else is gone. So first we have to cancel multiplication by 5/9. Ooh, how do we do that? Well, remember when we canceled multiplication by 1/2 by multiplying it by 2? What we actually did invisibly was multiply by 2 over 1. So the 2's canceled out and the 1's canceled out. This is important because to cancel fraction multiplication, you just multiply by the flipped version of the fraction. We call that the reciprocal. So to cancel the 5/9, we multiply by the reciprocal, 9/5. The 5 on top and the 5 on bottom cancel each other out, and the 9 on top cancels the 9 on the bottom. So both fractions are now gone. Make sure that you also multiply the other side by 9/5. Now we see that 9/5 C is equal to F minus 32, which will be easy to solve. You just got to add 32 to both sides. So now we found out that to convert Celsius into Fahrenheit, you just multiply it by 9/5 and add 32. There are a bazillion more formulas in the world, and who knows which ones you're going to have to manipulate in your future career. Just keep studying algebra, and you will be ready for any formula that gets thrown your way.